on 14, what? I guess I'll write it out. It looked like a suspicious that I had it. And A was 29.7. Had we calculated B or anything?
14.
Oh. So had we calculated A?
We did, but we went through in the last 5 minutes.
Okay. So you want to do angle A again, huh? All right. And angle A is 890. And B is 697. So if we want to do angle A, we have to use the relationship sine A over little a equals, and we have the B, so that's a ratio we want to use, sine B over B. This is given to us, this is given to us, so we're going to calculate, and then we're going to calculate this A. So if we kind of solve this, it's going to be this way. We're going to ultimately do the sine inverse of this thing, right? I kind of cut myself too close. And then little a is 840. And then sine of B is 48.2 all over small b is 697. This is 890. All right. So let's come out second sine inverse 890. Didn't turn on, but I did. Okay. Second sine inverse 890 times the sine 48.2. And I didn't check to see what this was in, so I'm gonna force degrees. And then divided by 697. Okay. I did the sine inverse. That says it's 1.25 degrees. Did I get that right? What's that?
I think there's something in front of inverse.
This,
the funny character originally when you had it up there.
I'll do it again then. Second sine inverse. Times 48.2. That's a 9897. Got it again. 1.25. Is that what I got last time when I was doing this thing? What? I'll switch it over to degrees just in case it's that 125 is some sort of a radian thing. I'll go second, sine inverse. Now it's in degrees mode, so I don't have to worry about that. Yeah, that 1.25 was a radian deal. Just for curiosity, I wonder what second. I'm trying to convert that 1 point. This probably isn't the right way to do that, is it? I don't know. I think that 1.25 is radians. I think that's what that is. I'll just leave it alone. It's 72.2 degrees. Now, what we have to do is we have to decide whether or not we have two triangles. And then what you're going to do is do an A1. And when I did this sine inverse, it's either going to be 72.2 or else it could be 180 minus that, right? Supplements are the same. So that would say, what is that, 107.8? If we took the sine of 107.8, I subtracted right, didn't I? Or 72.2, I would get the same sine. So this is the possibility, and now what we have to do is then we would have to say that 107.8 plus this, and is there an angle here that would sum there? So what I have to do is I have to see, is there a C2 that would also satisfy it? And that would be 180, because that's a amount of degrees in the triangle, minus the sum of this 107.8 plus 48.2. So this is 180 minus, this is going to be 156, isn't it? When I add 107.8 to 48.2, that's 156. Then I subtract that from 180, gives me 24. So I could have a 24 degree. So I could have A1 be 107.8, B be 48.2, and C2 equal 24.0, or else I could figure out what this C would be. That C right there is going to be 180 degrees minus the sum of these two angles, 72.2 plus 48.2. What in the world? 4. Did I add those two together at 130.4? Then subtract that from here. That'd be 149.6. Is that right? How's that? This is 120.4. Yeah, you're right. So then this would be, okay, yeah, okay, 39. 59.6, is that what you said? So the two triangles, this is kind of a mess here, but the two triangles that we could have, you could have a triangle of 72.2, 48.2, and 59.6, or we could have a triangle of 107.8, 48.2, and 24 degrees.
But we still need to keep our side.
The side C, we could use this one, because the side C is not going to change between this triangle and this one. So it'll just be side C, and the way we find side C is we would use the law of sines and do C equals the sine of C over, and we'd want to use the angle that was given to us was this one, right? This is the angle that was given to us in the problem. So we'd want to use that ratio. We would want to use B sine B. Otherwise, we might have rounding errors. So this is going to be C sine of 48.2 times 697 over. I did this. This was wrong. Sine 59. That's 59. So that's sine C. 59.6. And then sine of B. Sine of 48.2. Is that what everyone got? 806?
That's what I thought.
Okay. All right. So this one is the example of having two angles. And one thing that we learned is that you better have it set up in sine mode or in degree mode. Otherwise, it's going to give you radian back. So have your calculator set up that way.
Now you have to figure out the length for if C was the other angle.
No, this length will be the same. It doesn't make it. What it is one is. I won't be able to draw it correctly, but one is something that the triangle would look like. That 806 would be a length that if it was 806 here, and you brought it around right here, and this would be 806. If this were at such an angle that this side was longer so that it came back up on the back side, then it wouldn't work. That side's the same side, no matter which. It's just one, you have an obtuse angle, 107, and the other one, you have 72.
But the lengths would be different.
No, its legs are the same. Same length leg. It's showing you on page 213, the fourth one down,
On what page?
313, the fourth one down. That side is the same length. It's just that one place you have an acute angle and the other one you have the obtuse angle. See, we have an acute angle or we have an obtuse angle. But that side, and in this case the side is this C side, which is the side, is going to be the same length. I guess the sides are the same length.
Well, if they're the same length, then how would B be the same length? Because if there's all three lengths are the same, there's no way you can improve the triangles. You see what my question is?
Yeah, I see what you're saying. But C, it'd be the
Whether
side,
it's C or D,
the
count
side,
is-
the side that would be different would have to be the side. It's not, let's see, I gotta think about this thing.
And do we have to figure out that? So if we don't have to figure out that measurement, then it's uniform.
Yeah, this side is the same, but the side that's going to be different is that
Easy, so we can have safe angle.
yeah, B has got to be the same because that angle is always the same. So in terms of what it's given to us, this is the angle B, and the two angles we calculated are here. This has got to be A, and this is A1. then this is C. So I guess what you would be right is this side would change. It would be a C1 over here. I'll stand corrected. Because when it's this one, then it has to be this side length. Or else it has to be this side. Where we got which one? This right here. What it is you take this angle right here and you add this angle right here. And that's 156, and that gives you then this angle. But there would have to be a C1 associated. Yep. Well, what we're doing is this angle right here is the 72.2, and this angle right here is the 107.8. How could this couldn't be an obtuse angle? That'd have to be an acute angle. See, and then this big one here is the 56.6, and this is the 24. So then there would have to be a C1 that would be opposite that 24. So C1. Would have to be sine of that CB over sine B. And that one does not change. This length and this length don't change. So then this is going to be the sine of the 24 degrees. And then it's B, which is 697 over sine of 48.2. So we go sine 24 times that'd be 380. So then that'd be 380. Then this side would be 806. And that'd be 24. A would see that this side here stays unchanged. This is angle A, this is angle A, but that side stays unchanged. And this length here, the side opposite angle B is 806, it stays unchanged. But the this side here is the thing that changes. See? Because this is 107 and this is 72.
So they sign the same.
Yeah, yeah. See, that side stays the same. All right, so we can try another one. These things take a long time to do when we have two different angles. We'll see if we can figure one out. So one that has two angles again is 23. So leave a little room here so we can get this. Okay. This one at 72.2. Okay, the one that can possibly have two angles is going to be C, because that's the angle we don't know. This ratio is going to stay constant. So we'll do sine of C over C equals sine of B over B, because that gives us the stuff we know. So to get that angle C, we're going to do the sine inverse. 145 is side C, sine of 72.2, and B is 78.3. $145 times sine, that's 72.2, divided by 78.3. Oh, dang it. How in the world did I? No, I didn't put 3. 72.2. Delete. Ah. Telling me I have a bracket wrong.
No, that's what I get too, the sine inverse. Out of range, or sure it's not supposed to just be sine?
No, because see this thing here, this is the ratio I'm using, and it's this thing is equal to that. I'm bringing that value up. Then C has got to be sine inverse of this. Yeah, no such triangle. I didn't look for the right one. There's no such triangle. That side, the one, what's wrong with it? Okay, this is what's wrong, and I should have just calculated this out. If I do, clear it. If I do 145 times the sine of 72.2 divided by 78.3. It's greater than 1. No such, and that is in that scenario. So I guess what we should do is every time we do it, don't try to do too much at a time. Do the thing, then we can always go up after we get this thing calculated, is just do the sine inverse and go up and hit that. Because scenario 1 on 213 is when the sine of b is greater than 1. So no triangle. Well, let's see, we can, no, 25 is supposed to have 2 triangles. So let's do 25. $38 degrees. So the ratio we're going to use, we have this b, so it's going to have to be sine of b over small b equals sine of a over a. Okay. 11.8 sine 3840 over a. So we don't make the same mistake as we did before. $38.40. I don't think I have to put another bracket in. So now we got a sine of an angle and it's within range. So then I'll do the sine inverse. What? Did the wrong thing. Second sine inverse. And then I want to go up here. So it's 49 degrees, 33 minutes. And that's B. So what I did was I did that. B equals sine inverse of that thing. 49. Now I got to do, I do degrees, minutes, and seconds. I do it first or I bring the answer down. .49, I guess I answered my own question. 49 degrees, and I'm going to make that 20 minutes. And I'm doing B. Now, what I have to do is I have to see whether I have a B1 that works. B1. Now to calculate B1, I have to take 180 minus this, right? So B1, because its supplementary angles have the same degree. 30 degrees, 20 minutes. So that's going to be a 40-minute deal. And that's 79. So what is that? 130? Is that right? No, that's right, isn't it? So this would be B1. Now, you didn't get 49.20?
What did you do in the calculator after you had 49.33?
Second angle, at the bottom, here and there shows you, right triangle, it says ENS. Stands for degrees, and then
Yeah.
convert it for you.
Yeah, if you just,
Round it to the same second or minutes, because the other one was only minutes.
yeah. I just rounded it to minutes because, see, it was 49.19 minutes and 51 seconds. So, you know, the other one is in minutes, so you can't get seconds with this one. Otherwise, you know, you're just not that accurate.
First time you used the ENS.
Now, there's going to be a C and a C1. And we get them both in the same way. C1, if it exists, C1 is going to, there's 180 degrees in the triangle minus the sum of this angle and this angle. 38 degrees, 40 minutes, plus 130 degrees, 40 minutes. So that's 180. And 40 and 40 is 80. Take 60 out of there, that's 20 minutes left. And add a degree, right? So then that's going to go to 9. 169. And then it should be 40 minutes. That's 79, so that's 10. Is that right? 10 degrees, 40. And then if I figured out C, this C is going to be calculated that same way. It's going to be 180 minus the sum of the 38 degrees 40 plus 4920. I'm gonna go up this way. 180 degrees minus 40 and 20 is 60, so that's an extra degree. This would go to 50. 88. 92. So the two triangles, they would have a common 3840. This one would be a 38, a 49, 20, and a 92. The other one would be a 38, 130 degrees, 40, and 10, 40. Then what there's going to be is there has to be a C, and what's the C? It's not too good at trying here. This is the one that has the same length in it. This is the common angle A. And this is going to be the B and B1. This will be C. So we're going to have a C with a long one and a C with a short one. Right? So to do this C, it's going to be what we're going to use is C sine of C. And then we want to use the stuff that was given us. The A was given to us, right? So we want to do little a sine A. So then C is going to be sine of C 92. A is 9.72. And then sine 38. No, this other one, C1, this ratio is going to stay the same. That 9.72 over sine of 3840. But rather than 92, I'm going to have sine of 10 degrees, 40 minutes. So if I do that 972 sine of 38, then I could just copy it. So 9.72 divided by sine of 38. And 40. That gets that. Then what I'll do is I'll do sine of 92 times that. So and I can. So that's 15 point, I don't know. Whatever. This should be 15 point, whichever one you want to do, 5. I'll just do 5. And then for the C2 or C1, then we want to do that sine of 19 or 1040 sine. And I'll take it times where what it's times this one up here. Two point, I don't know, doesn't make too much difference. 2.9. Tedious things. So, what? Oh yeah. What you do is right here. Once you get the supplementary angle, then if you add the supplementary angle to that angle that's given to you, it's got to be less than 180. Then it will be, if the sum of this 38 and this supplementary angle to the 49 added to more than 180, you wouldn't get a second triangle. Well, the one was because it got to be more than 1, like this one. This value right here was more than 1, and so you can't have it because that's in the example on page, or the written out on page 313. That is that first situation where it says the sine of b is greater than 1. So if you get a number that's this number inside here, if that's greater than 1, you can't do a sine inverse of it. And then if you do have it less than 1, then it can be either the third or fourth situation. The third situation would be if the sum of this angle and the supplement to this angle sum to more than 180, then you couldn't get this. See, if those two sum to more than 180, you wouldn't get this. So what you do is you calculate this angle, because the things that we were given in this problem was this and this and this. And with that information, we can get this angle. And then from this angle, the supplement of that angle, which is 180 minus that angle, which is 130, is the possible other angle in a triangle. Then to see if that triangle exists, you add that 38 plus this, and it has to be less than 180. If it's less than 180, which this was, then there is a second triangle. Okay.
So those questions you handed out, that's a take-home test? Or?
Yeah, you just do it, and it's going to be a couple problems in every section of 3. Yeah.
So we have regular class Wednesday, regular class Friday.
Friday.
Next week is finals. Right?
Next week is finals, and there's no regular classes. What you're going to have is I'll find out from Catherine if she's in here in the morning. If she's not in here in the morning on Monday, then you can come here during Monday. But I want you from 8 o'clock till about 2. You can start. And then if you can't get it done on Monday, then Tuesday, contact me and tell me, because I don't want to have to come in 8 o'clock 2 days in a row. Yeah. So you don't have to come in at 8. You can come in at 10 or 12 or 1, just starting before 2. Go ahead. Then that's done. Then you're done. You're done with the course. Done with the year. Corey?
We're looking for a second triangle. Do we look for a second triangle if it gives us 2 angles right off the bat?
Well,
If 2 angles are given?
when you'll have to look for 2 possible 2 triangles is when you're given a angle and 2 sides, which and it's a not included angle.
Okay, so we only look for one if it gives us angle and 2 sides.
Well, a not included angle and 2 sides. If you've got an included angle, then we're going to look at 7.3, and that requires the law of cosines. So if you have 2 sides and an angle that's not included between the 2, then there's possibility of having 0 triangles, 1 triangle, or 2 triangles.
Like if you have angle A and side A, side B, something like that.
Yeah.
Yeah. It gives you like angle A, angle B, they're not automatically.
Angle A and angle B, then it's 7.1 applies, then it's only the law of sines, and there'll only be 1 triangle.
Okay.
Do you want our
Thank you.